We're going to look at circles and the equations of circles in this video. We're going to start off with the simplest equation of a circle, which is one which is based at the origin. In order to find the equation of this circle, we're just going to take a general point anywhere on the circle, x, y. We'll choose one in a different quadrant in a second just to see that it doesn't make any difference. And we're going to have a general radius r. Okay, so how are we going to turn this information into an equation? We need to think what we know about a circle. A circle is defined as the set of points which is the same distance from the origin. All of these points are equidistant, the same distance from the centre of the circle. So, how do we work with distances? Generally speaking, when we're working in coordinate geometry, if we need a distance, or we know a distance, we can use Pythagoras to calculate that distance in terms of its x component and its y component. So if we just label the sides of this triangle, x, y, r, and we know that's a right angle triangle. Therefore, we can just use Pythagoras' theorem. X squared plus y squared is equal to the radius squared. And that's the equation of our circle. If we did take a different point, let's say one over here, we had a different x and y. Remember, it's a circle, so that's still going to be r, despite my lousy drawing. That distance there would be negative x, and this would be negative y. But if we square negative x and we square negative y, that would be exactly the same as x squared plus y squared. And we know that that would still equal r squared. So that will work for any point on our circle. Now what happens if we move the origin, move the centre of the circle away from the origin? Okay, so there's our attempt at a circle. Centre, we'll say that this has centre 3, 5. We'll have some actual coordinates for this first one. And let's have an actual radius now. Let's say its radius is 7. Again, we're going to choose a general point, x, y. Again, this could be any point on the circle. And we're going to create our right angle triangle again, because that's all the equation of a circle is. It's just Pythagoras' theorem. So if we want to know this distance here, we go up to x on the x-axis, but we started at point 3, so we'll need to take away the 3 that we travelled to get there. That's going to be x minus 3 squared, because we're going to use Pythagoras. This distance here, we're going up to y, but we started at 5, so y take away 5 squared. And we know that's going to equal 7 squared. Therefore, the equation of this circle will just be x minus 3 squared plus y minus 5 squared equals 49. So you can see we get the centre of the circle by looking at these here. So it has centre 3, 5. Notice again, anything in brackets, you're basically solving an equation. So we'll have the x centre will be 3, the y centre will be 5, despite this reading x minus 3, y minus 5. And the radius will be the square root of this, 7. Okay, and again, that would have worked with any point, even if I was over here. We know that distance there is 7. If this were the point xy, that distance there would then be 3 minus x, but again, if I'm going to do 3 minus x squared, because I'm squaring it, it doesn't matter which way round I have the signs. X minus 3 squared is the same as 3 minus x. Check that. Same thing, just in a different order. The same would work with the y. So that is how we get the form of the equation of a circle.